NASA has set its sights on Mars. Its goal is to send humans to the red planet in the next 20 years.
Looking up at Mars in the sky, I really do feel like I'm looking at a place that someday there will be people walking around on it.
It feels so much like Earth in so many ways, and it's a place that really captures my imagination as a result.
It's the most Earth-like environment we see in our solar system. So we're not going to leave it alone. We're going to try to do this.
But conquering our planetary neighbor is a tougher challenge than we ever thought possible.
It's an isolated environment where a million things can go wrong, where there's absolutely no hope of rescue.
There are so many hurdles to overcome for human exploration of Mars, and it makes it quite difficult. Sure, we can get there, but are we going to be in one piece?
Sometimes it feels like Mars is designed to keep us away.
Are we doomed to fail in this endeavor? The red planet, Earth's neighbor, and the destination of NASA's most ambitious mission to date. But this expedition will be harder than we ever thought possible.
It hurts to think of how hard it is. It's the farthest a human being has ever been from the Earth. We gotta take every precaution.
As NASA astronauts arrive at Mars, they will face a huge obstacle. Landing on the planet is a daunting task. In the past, Mars hasn't always rolled out the welcome mat.
Mars is kind of like a graveyard for spacecraft. It's actually really hard to send something from Earth and land it on Mars.
This is how the European Space Agency hoped its $250 million Schiaparelli lander would touch down in 2016. But the lander's systems got it wrong. The parachute detached early, sending the craft into free fall for 33 seconds. Schiaparelli smashed into the surface at 335 miles per hour, leaving a deep black scar in the Martian landscape.
It turns out that Mars is actually a particularly difficult planet to land on. Even humanity's most brilliant engineers, we've got about a 50% success rate when it comes to landing on Mars.
The red planet is littered with dead spacecraft that didn't nail the landing. And for NASA's first crewed descent to Mars, the space agency must learn from these mistakes. But as the crew hurtles towards the surface, they're battling the same problem as all the landers that failed before. The Martian atmosphere is 100 times thinner than Earth's, so it can't provide the drag needed to slow a spacecraft down.
So it's not like the Earth where you can have these big giant parachutes that gently glide you down to the surface. You can use some of the air, but it's hard.
The red planet's thin atmosphere is a problem that has been billions of years in the making.
Mars doesn't have a large atmosphere because it's constantly being peeled away due to the lack of protection of a magnetic field.
The solar wind can strip away an atmosphere. On Earth, a liquid metal core creates a magnetic field, which shields the planet and helps maintain the atmosphere. But Mars is different. 4.5 billion years ago, Mars and Earth formed from dust and gas in space. Mars formed where building materials were scarce. Its growth was stunted.
So Mars is much smaller than the Earth. It's a factor of 10 smaller than the Earth. And that factor of 10 in mass is important. All of that extra mass allows the inside of the Earth to stay warm and to have a core that's rotating which generates a magnetic field.
4 billion years ago, the churning heart of Mars started to cool and solidify.
And with no hot core, there's no magnetic field being generated. All of the high-velocity charged particles coming from the sun pick away at the atmosphere and slowly tear it away.
We know it's losing atmosphere every second due to the solar wind. So, bye-bye atmosphere.
With little Martian atmosphere to work with, NASA had to be creative to get its crewless landers to the Martian surface. In 2012, the revolutionary Sky Crane landed the Curiosity rover using parachutes and retro rockets.
Previous missions have used both a parachute and something else, like a bouncy ball inflated around the spacecraft.
I don't think a human crew is going to be too pleased if they're going to be bouncing onto the surface in an airbag rolling to a stop, right?
To land people on Mars, NASA needs some new tricks. The 2020 rover will overcome the challenge with the Advanced Supersonic Parachute Inflation Research Experiment. Aspire. It will rapidly slow down the craft with the force of an airplane jet engine.
This is fine for the rover. It's actually going to work no problem, but it's not going to work for people.
A human lander will weigh far more than the 2,300-pound rover. Not even supersonic parachutes could land a crew safely on Mars. NASA will need a new plan. One idea is to use the thin Martian atmosphere in a unique way.
There's an idea of coming in really fast, getting to the thick part of the atmosphere, and then going horizontal to the ground and gliding and losing your momentum that way.
As the astronauts descend, they tilt the nose of the lander towards the Martian surface, aiming for the thickest part of the atmosphere close to the ground. Then they pull up at the last second, using friction from the atmosphere to slow the craft. Descent engines switch on for the final touchdown.
Is this a crazy idea? I mean, yeah, it's a little bit weird. I don't know if we'd really think about it doing something like this, but I mean, you've got to think outside the box sometimes.
Right now, NASA's plan for landing a craft on Mars are still on the drawing board. But even if they can get astronauts onto the surface, the thin atmosphere isn't done with them yet. It causes swirling dust storms that cover the planet's entire surface.
Mars doesn't just have dust devils, it has dust hell.
And these towering clouds have killed before. If NASA's astronauts arrive on Mars as planned in 2035, the settlers will find one of the red planet's biggest challenges is its dust.
It's sticky. Basically, light from the sun can give this stuff a static charge, and then it clings to stuff. So it's not just a matter of standing on a doormat outside your space habitat and shaking yourself off.
It's going to get in your spacesuit, it's going to coat your visor, it's going to cover your solar panels.
If you get it in your lungs, it's not a good thing. We have to figure out how to clear this stuff out.
300 feet, minus 11.
Through the 60s and 70s,
There you go.
Apollo astronauts walked on the moon. When they returned to their landing module, they brought moon dust back with them. The lunar dust clogged seals, caused equipment to overheat, resulted in false instrument readings, and even made astronauts sick.
You don't want to be breathing in fine, dusty material. By itself, you can get things like silicosis. It's a almost basically a lung cancer that you can get just from breathing the dust itself. You don't want to do that.
The red planet is covered in sticky dust. And new research suggests it all came from one place. The Medusa Fossae Formation. When the 600-mile-long volcanic deposit formed 3 billion years ago, it was around half the size of the United States. But the Martian winds have eroded this structure and spread the dust across the entire planet. When the wind whips up this dust, it can have disastrous consequences.
The real problem is just that all these fine particles get lofted into the atmosphere, and it takes a really long time for them to settle back out.
And what the dust does is it just gets up in the sky and it sits there and sits there and sits there.
As more material gets lifted into the atmosphere, it forms huge dust storms. The storms are so huge, they block out the sunlight and cool the Martian surface, creating a temperature difference between the ground and atmosphere that causes winds to increase and the storms to grow. And NASA's Opportunity rover knows firsthand the dangers of being trapped in one.
Opportunity was a NASA rover sent to Mars to hunt for signs of past water on the surface and potentially signs of past life.
This is a rover that we really worked with so long, knew so well, and who had come up with so many amazing new results from Mars.
June 2018, Opportunity was 15 years into its mission when giant clouds of dust appeared on the horizon. NASA could only watch as the storm grew and grew.
Once this dust storm coated the entire planet, it blocked the sun. And the sun was the source of Opportunity's power.
Opportunity works using solar panels. And so it gradually got less and less and less electricity.
For Opportunity, there was no escape. Lost in the darkness, Opportunity's power reserves slowly ran dry. The rover fell silent.
We thought, well, maybe once the dust storm clears up, the panels can, fire up again and we can get it back, but it just never woke up.
If NASA astronauts do make it to Mars, the storms could damage more than the crew's power supply. When the storms begin to blow, they crackle with electricity.
Just like you can create a static charge by rubbing your foot on the carpet or a balloon on your hair, this happens at large scale in these dust storms on Mars. The sand grains rub up against each other and that creates the static charge. So you get these electrical flows that occur.
Here on Earth, we see this in volcanic eruptions as the dust, the ash, burbling out of one of these huge eruptions. You'll see lightning discharges in those volcanic plumes from this same charge transfer.
If you're at a place with a lot of electrostatic discharge, that means sparks are going to fly, which is really terrible for operating instruments.
To survive on Mars, the settlers are going to need a protective shelter.
The key word to living on Mars is protection. Protection from the cold, protection from the lack of atmosphere, protection from the radiation from space.
NASA could build shelters, but Martian history offers them a shortcut. Millions of years ago, the planet's volcanoes erupted huge amounts of lava.
But the silver lining is that as the lava was flowing away, it did that through underground tubes. And then as the lava evacuated away, it left behind empty caverns, just like this really big lava tube that we're standing in right now.
Martian gravity is a third as strong as Earth's, thanks to the red planet's lower mass. So when Martian lava flows underground, it meets less resistance and can carve out monstrous cave systems. Natural astronaut shelters, hidden away from the red planet's dust storms.
If you actually then seal them, you can fill them with air. You've got a great place to live.
These tunnels are ready-made for people to move into. We already have the keys.
But a lava tube may not be everyone's idea of home sweet home.
Because they're a natural feature, you can't pick and choose where they are. You have to go to where they already exist.
Building their own shelters gives the astronauts more options where they can live. And they can be built by robots before the settlers arrive.
We could even send 3D printers. I'm talking about something that actually uses the rock there and makes something like concrete, and it could build structures for us to live in.
NASA challenged the tech industry to develop Martian shelters built by autonomous robots.
It sounds like something out of a wonderful science fiction story, but we already have this technology. We on Earth can actually 3D print houses already by actually just adding concrete. So we have all of the technology necessary to do this. Now it's just, do we have the will?
In May 2019, NASA announced the winning team. AI Space Factory built a structure that withstood rigorous pressure and impact testing. It can be 3D printed in 30 hours and made from materials found on Mars. Once scaled up, the habitat could protect settlers from the inhospitable conditions on the red planet. Even with shelters, the settlers will need to eat, breathe, and drink. But there is no food, breathable oxygen, or liquid water on Mars.
So even though Mars is the closest friendly environment to life that there is to the Earth, it's really not all that friendly.
Without easy access to the essentials of life, will settling on Mars be possible? Humans have evolved to live on Earth. We have oxygen to breathe, water to drink, and food to eat. Everything we need to survive. Compared to Earth, life on Mars is a recipe for disaster.
If you look at it as a human being who wants to live there, yeah, this is an alien world that's going to try to kill you at every step.
It's far away, it's cold, there are just so many reasons why we really wouldn't be happy campers on Mars.
So why on earth are we talking about sending people there? Well, the next closest planet, Venus, it's way worse. Its surface is super hot. It's got horrible chemicals in the atmosphere. So in comparison, Mars looks like a great, great place to visit.
It's close, it's relatively Earth-like. And although there are many challenges, they're challenges that we could overcome.
To settle on Mars, NASA's astronauts need a few essentials.
If we want to live there, short-term or long-term, what do you need physically? Well, you need air, you need water, you need food. Those are all things that we can bring with us, but it's a lot easier if they exist there on Mars.
The settlers will need to grow their own food, but the Martian ground is poisonous.
Mars's dust looks really benign. It looks kind of like dust you would find in southern Utah. But it turns out it contains a lot of something called perchlorates. And these materials are really toxic to human life.
Perchlorates are chemicals formed by electricity produced in Martian dust storms. And they make up around 1% of the Martian soil.
Which doesn't sound like much, but this could be a significant problem for any humans living on the surface of the red planet.
Food grown in the Martian dirt will absorb the perchlorates, posing a health hazard for the astronauts. But that's not all. Direct exposure to the toxic soil will make astronauts very sick.
One of the effects that perchlorates have biologically in our bodies is to sort of mess with and alter the function of our thyroid glands.
Astronauts will get rashes, feel nauseous, extended exposure to the dirt could even kill them.
And Mars is not the sort of place where you would ever want to get seriously ill, millions of miles from all the hospitals and healthcare of the Earth.
There are ideas of how to clean the poisonous soil using water or bacteria, but the technology is not ready. The first settlers will need to find a safer way to grow food, and NASA has the solution. Hydroponics will provide all the food a Martian settler might need. Instead of growing in soil, the settlers will grow crops in water.
So all you need to do is bring the seeds or the plants and then have them grow right there in water. But if we decide to grow our crops hydroponically on Mars, then we still have this problem of needing lots and lots of water.
But before astronauts water their plants, they'll need water to drink. And Mars hasn't had running water for millions of years.
We've all seen the movies of people stranded in different places and having to survive, and they can last for months without food. But a human cannot last beyond 3 days without water.
Astronauts on the International Space Station recycle water from bathing, breath, urine, and sweat. But they still need 1,500 gallons sent up each year. Each delivery weighs over 6 tons. Transporting water to Mars will add a lot of weight to the manifest.
You have to use fuel to launch it, but then you also have to use more fuel to launch the weight of the other fuel, and so on and so on. You have to keep to an absolute minimum the amount of weight you try to launch from Earth.
So if NASA wants to set up residence on Mars, astronauts will need to find a water source. 2019, the Mars InSight lander was on a mission to uncover secrets about the red planet's interior. But on April 25th, InSight's onboard camera snapped something promising for the astronauts' water hunt.
One of the most exciting observations we've made of the Martian atmosphere is actually seeing water vapor clouds come and go, just as you might see on a summer's day on the Earth.
These are very thin, wispy clouds that are up very, very high. So there is some water vapor in Mars's atmosphere. It's just not very much, not nearly as much as Earth.
And this is really exciting because it tells us that there's still some kind of a water cycle on Mars.
These are noctilucent clouds formed in the upper part of Mars's thin atmosphere and made from water ice. Like their Earth counterparts, they float so high that the sun illuminates them even at night. But in order to form, they need help.
There are little bits of fluff out there in space that burn up in the atmosphere of Mars just like they do here on Earth. But they may be creating little particles in the atmosphere that water can condense around. We call these condensation nuclei. I love that term. So it's possible that meteors burning up in the atmosphere of Mars are making these little tiny grains of dust that the water vapor is condensing around and forming the clouds that NASA's InSight lander saw.
These clouds are too thin for it to ever rain on Mars. So if there's no rain, the astronauts will need to find another source of water. Even though no liquid water exists on the planet's surface, there are other places to look.
It turns out there is a lot of water on Mars. It's trapped underneath the ground, beneath the dirt and the soils at high latitudes. It's also found in huge volumes up at the polar ice caps.
Ice, you melt and it becomes water. You can drink it. Yay! You can grow plants and do things like that.
In fact, if you were to melt all of Mars's polar ice, then you would be able to cover the globe in water.
So ice is an extremely important thing to have access to. So if we do go to Mars to explore and live there, following the ice is the way it's going to go.
Even if NASA astronauts can turn the Martian ice into drinking water, without another resource, settlers will be dead in 3 minutes. That resource is oxygen.
There is oxygen on Mars, but it's not in the air. You can't breathe it. It's bound up in the dirt and combined with iron to make iron oxide, giving it its characteristic red color.
And so we need to bring it with us, and that's a huge amount to bring, or we need to make it at Mars, and that's really difficult.
We can deliver oxygen to the ISS, but the trip to Mars is long, so there will be few supply missions.
Once you're on Mars, you can't pull out your app and order an oxygen delivery to your door. You got to take it with you, and that's a lot of oxygen.
NASA astronauts will need a way to make oxygen on the red planet, and the space agency is working on a solution. When their 2020 rover arrives on Mars, it will carry out the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE.
MOXIE will take carbon dioxide from the Martian air and use electricity to split that CO2 and release oxygen that astronauts could breathe in the future.
This test will create oxygen on another planet for the first time. But MOXIE can't make enough for a crewed mission to Mars.
MOXIE will be able to make about ½ pound of oxygen per day, which is only enough to keep a human alive for about 6 hours.
NASA needs to significantly scale up the technology to support a whole crew on Mars. But even if the astronauts can survive on the red planet, can they actually reach it?
This is a long trip in a bathtub with 3 other people. It's really challenging. I think we're still asking ourselves this question, how will we do it?
NASA plans to put boots on Mars. To achieve this, you need to carry a lot of stuff.
You need oxygen, you need medical supplies, you need food, you need stores of water, you need some fuel if you want to come back. And all this has to be packed into an incredibly tiny volume.
NASA's solution is Orion, a 28-ton spacecraft, nearly twice the mass of a school bus. The rocket that launches Orion will need to produce millions of pounds of thrust. And that's a problem.
If we decided tomorrow, like, hey, you know what, let's go to Mars, we can't. We don't have powerful enough rockets to do it.
In 1969, NASA's Saturn V rocket fired Apollo astronauts to the moon with 7.6 million pounds of thrust. That's the power of more than 34 jumbo jets. A Saturn V could have sent astronauts to Mars.
Not anymore. We stopped making them.
To break free from Earth's gravity, the space rocket must travel at 25,000 miles an hour. To achieve that, NASA is building the most powerful rocket in the world.
The Space Launch System, or SLS, is the rocket that's being designed to carry Orion off of Earth and beyond low Earth orbit.
And the philosophy is, hey, remember those big rockets that we used to make back in the 60s and stuff? Let's do that again, but more so.
It's really big. It's larger than the Saturn V rocket that was built to carry the Apollo spacecraft, and is therefore going to be the largest rocket built.
The Space Launch System will be taller than the Statue of Liberty. Its gargantuan engines will thrust the rocket through the atmosphere with a horsepower of 160,000 Corvettes, producing 8.8 million pounds of thrust. The SLS will be able to blast the Orion capsule into space and send it on its way to Mars. Unfortunately, the rocket has fallen behind schedule. Its maiden test flight was set for December 2017. Now it's scheduled for the end of 2020. Critics see the SLS as a waste of money, with the project reported to be billions of dollars over budget.
The key to doing any of this is to have the access to space be affordable. If it's out of the question to spend the money to do it, we're never going to be able to do it.
And with SpaceX developing reusable rockets, NASA's single-use SLS is beginning to look even less appealing.
The reason air travel is inexpensive is because we figured out how to use planes over and over again, basically. If we can do that with rockets as well, we don't have to keep building them over and over again.
It's still hoped NASA's Space Launch System will go to Mars in the 2030s. But even though the red planet is our neighbor, the timing of our visit will be complicated.
If you're planning a family vacation and you want to get in the car, it's easy, right? You look at a map and you say, I live in city A and I want to go to city B and I'll just take the highways there. Well, great. Now imagine that city A is moving this way at 50 miles per hour and this city is moving this way at 200 miles per hour. Now what do? Well, that is a very small problem compared to getting to another planet.
The timeline of a Mars mission, the scheduling, if you will, is all governed by celestial mechanics, the orbits of the planets. It's not just you pick a time to go to Mars randomly whenever you feel like going. You literally got to wait for the planets to be aligned, right?
On average, the distance from the Earth to Mars is about 140 million miles. But this is changing all the time because we are both planets that are orbiting the sun. So about the closest that Earth ever comes to Mars is a distance of about 35 million miles.
But in other times, when we're on the opposite side of the sun from Mars, it can be as much as 250 million miles.
Launching near the time of Mars's closest approach shortens the journey. So NASA can save on fuel and resources, boosting the mission's chances of success. But this planetary alignment only happens every 26 months. So if NASA misses a launch window, it will have to wait for over 2 years for another go. But simply picking the right time isn't enough. Mars and the Earth are both orbiting the sun, so Orion can't fly in a straight line to Mars. Instead, it will use what's known as a Hohmann transfer.
What we want to do is sort of put ourselves on our spacecraft in orbit around the sun. So we might start right here on Earth, launch our spacecraft, and essentially we just make a nice gentle arc that's arcing around the sun so that it can naturally slide into this orbit and then end up on Mars.
The journey will take around 10 months. To get there quicker means burning more fuel, which isn't an option. The Hohmann transfer keeps fuel usage low by pulling the craft in an orbit that gradually intersects with the orbit of Mars before being captured by the red planet's gravity. But they need to get their direction just right.
The way the orbits work, you've got to aim in a little bit different direction from where Mars appears to be now. You got to aim for where it's going to be when you get there.
This has to happen so that it can naturally slide into this orbit and then end up on Mars. If we miss that precision, then we just could end up hurtling out into space.
Even if NASA hits their target, the crew has a long 10-month journey in space.
The human body is just simply not designed for long-duration space travel.
Space travel can destroy bones, weaken heart muscles, and even mess with the mind. Could a crew survive the journey to the red planet? NASA plans to put humans on Mars in the 2030s. Rocket technology will be pushed to its limits. But the greatest hurdle is our own fragile bodies.
Out there in a spacecraft between the planets, all bets are off. It's going to be a dangerous trip.
Both hands down about the fourth rung up.
When astronaut James Irwin stood on the moon, his heart beat irregularly. Back on Earth, Irwin suffered heart attacks, which eventually proved fatal. A 2016 study found that the Apollo lunar astronauts are 4 to 5 times more likely to die from cardiovascular disease than astronauts who never left Earth's orbit. One cause could be space radiation.
And the radiation in outer space won't just be damaging the heart muscles, but also the nervous system and astronauts' brains in outer space.
Astronauts heading to Mars will face radiation created in the core of stars. Some comes from our sun, when solar ejections throw out streams of deadly charged particles. There are also cosmic rays from outside the solar system. Created in supernovas, the deaths of giant stars, these energetic particles race through the galaxy at close to the speed of light.
And you don't want to be exposed to too many of them. In low doses, it's not a problem at all, really. But in high enough doses, these things penetrate our cells and damage our DNA, and over the long term, can cause really bad damage to human bodies in space.
The longer you stay in space, the greater the danger.
Remember, our missions to the moon were on the order of a week or two. A mission to Mars, at the minimum, is going to be something like 2 or 2.5 years, probably.
These cosmic bullets can cause mutations and even cancer. New research from 2019 suggests space radiation will cause memory loss in 1 in 3 astronauts on a mission to Mars.
And it's not just a problem of forgetting where you've left your keys, trying to cut them back in through the airlock. You do not want to be forgetting emergency procedures.
So we're going to have to really consider, how do we mitigate the effects of this radiation to make it possible for people to go to Mars and actually spend some time without being ill?
So the ship needs to protect the astronauts.
Well, you'd think, well, just, I don't know, build a spaceship out of really thick lead. Like, well, that weighs a lot, and it turns out lead doesn't protect you from this kind of radiation. You need something else. Well, there is something else that protects you from this radiation, and that's water.
We need to bring lots and lots of water to drink and cook with, and if we just place that water in a layer around our spacecraft, that can absorb the cosmic rays.
You might think, well, you're drinking the very water that you're using to stop the radiation that's causing damage to us. Won't the water be dangerous to drink? It doesn't really work quite like that. You're just taking one high-speed subatomic particle and changing it into another one as it gets captured by the water. Water's still going to be safe to drink, fortunately.
But even if NASA can shield its astronauts from radiation, space causes other health issues.
Your bones are starting to demineralize. They're getting weak. You're getting arthritis, even in the prime of your life.
Weightlessness during the 10-month journey will thin the astronauts' bones. Muscles will waste away, making walking on landing difficult.
We've evolved, we've grown up on a planet with gravity. And as soon as you're an astronaut in outer space, floating around in weightlessness, it looks like a lot of fun, but actually your body is deteriorating from the inside.
Astronauts need assistance to walk when returning to Earth. If NASA's Mars crew arrives on the red planet in a poor physical state, they won't be able to function. Intense exercise regimes in space would help the crew stay fit and healthy. But we are in the dark about the full impact of extended space travel. On a mission to Mars, bodies would be pushed to the extreme. It's not just the physical challenges. Isolation is going to be a major problem for the Mars astronauts. They will be away from home for at least 2.5 years. So NASA is learning lessons from isolated humans on Earth.
Field studies in Antarctica are really good highlights of what it might be like to endure all of the challenges of spaceflight.
Because no one can get to you quickly. You're in literally the middle of nowhere on a big ice sheet.
And you're just sitting there in tents. We have 2 people per tent and about 8 people, and you're there for 6 weeks.
It's a really alien world. The sun never sets in the summer. There's nothing alive anywhere around you. Not an insect, not a bird, nothing. All you can hear is the wind. And the only people that you can speak to are your teammates. And it's for this reason that NASA uses some of these projects as training missions for their astronaut corps.
The worst part about being in Antarctica, which I think would be the same in long-duration spaceflight, is you really reach your limit. I think it really kind of highlights the best and worst of yourself.
Even the most introverted introvert on Earth still needs other people to live. And this is something that I think we don't really fully appreciate when we're on Earth.
What we found is that it helps to be really open and just communicate your problems. And so, gosh, I'm not feeling very well lately. I'm feeling a little bit of stress. I don't really know what to do. And you talk to each other and you work through those things.
Antarctica offers clues to how humans cope thousands of miles from civilization and helps NASA to plan medicines, communication strategies, and psychological tests to stop mental health problems jeopardizing a journey to Mars. But Earthbound simulations only provide a limited amount of data, and the teams know that in an emergency, they can be evacuated to safety. On Mars, rescue could take years, if it comes at all.
To say that sending humans to Mars is a challenge would be an understatement. We could be ahead of ourselves.
NASA's mission to Mars will be the toughest undertaking in its history. The launch from Earth will be a monumental challenge. The journey to Mars, filled with danger. And survival on the Red Planet will be a test unlike any it has faced before.
It's easy to make a bullet list of why going to Mars is hard, and that's going to be a long list, and those bullet points are going to be scary. A lot of these are serious problems.
Despite the challenges, the mission needs to be a success. Earth is in danger from climate change, asteroid strikes, and nuclear destruction. We need an escape plan.
Earth may just need a lifeboat in the future. We are growing very quickly, and we're using a lot of our resources. We're changing the planet.
If we're looking for a lifeboat, maybe Mars is the closest, best chance we've got.
NASA's goal is to send the Orion spacecraft to Mars in the 2030s. But to do that, we need a rehearsal.
I'd love to see us go to Mars. I would love to go myself, but it might be nice to have a little bit of practice before we try it.
Where better to practice than a destination closer to home?
The ultimate aim is to get humans to Mars, and one approach is to first have a goal of getting humans back to the moon.
Orion will first make the shorter trip to the moon.
There are a lot of advantages to using the moon. We can test out different scenarios for operations. We can also test out technologies much more close to home. And so if something were to go awry, we can much more easily intervene. It's a little bit safer. If we send people to Mars, it's going to be a lot harder for us to help them if they need it.
NASA's Orion moon missions will be far more than just a training exercise. It will use them to build a lunar outpost called Gateway, a space station in orbit around the moon.
It's actually a lot easier to do that than trying to build something on Earth and get it out of Earth orbit.
6 planned missions will build and maintain a space station in orbit around the moon. It will be a proving ground for the technology and science that will help us get to the Red Planet. And once NASA has ironed out any problems, the real mission can begin. Gateway won't simply be a small step for man, but a springboard to another planet.
When we first sent humans to another planetary body, it was the moon, and we had never done that before. So now we've got the moon under our belt. We know something about how to send people to another planet. We don't yet have all the technologies that we might need to send humans to Mars, but we're well on our way.
As NASA begins its journey to the Red Planet, not everyone is on board.
A lot of people think of Mars as our lifeboat, just in case we screw things up on Earth. But we really need to take care of our own planet.
If you want to go there and explore or build a base, more power to you. But I'm going to stay where it's a little bit more green and blue.
Even so, NASA is already building rockets and testing the technology. The stage is set for humankind's greatest adventure.
I think we will send humans to Mars. It's just a really, really, really big problem that we have to figure out how to solve. But we're good at solving problems.
Given the human mind and how curious we are and how much we like to climb the next mountain and achieve the next challenge, Mars is right there.
There is something in the human psyche that will send us to Mars despite all of the challenges. And so for sure, we will go to Mars.
Even though it's extremely difficult to go to Mars, the answer is always yes if somebody asks me if we should go, because that's the ultimate goal.